one of bonding, which is going to cover the following learning goals. We are going to be able to draw Lewis dot diagrams for atoms, ions, and ionic compounds after today. Okay, Lewis dot diagrams or other. Okay, we're going to first start off by drawing Lewis dot diagrams of an atom. Okay, so Lewis dot diagrams are also known as electron dot diagrams. So those two definitions or those two terminologies can be used interchangeably. They basically represent the number of valence electrons of an atom. Electrons are found in domains. And they are distributed within 4 electron domains with a maximum of 2 electrons per domain. So this is what I mean. Let's say if I drew a Lewis dot diagram for carbon, it would look like this. There are 4 electron domains, and all 4 of them are occupied. If we compare that to boron, say boron has 3. Out of the 4 domains, only 3 are occupied. Okay? Okay, now electron domains can have 2 types of electrons. If there is only 1 electron, this is called a bonding electron. We have 2 electrons that are paired up together. They're referred to as a lone pair. For example, if we are looking at fluorine here, these 2 electrons here that are paired up together is considered a lone pair. This electron that is by itself is considered a bonding electron. Therefore, fluorine can make 1 bond. So now, we have 3 lone pairs on fluorine and 2 bonding electrons on fluorine. We have 2. 1. We have 1 bonding electron. Here we have 1 bonding electron on fluorine. For a total of 4 electron domains occupied. Okay, I want you to try this one on your own. How many lone pairs or bonding electrons does neon have? Then I want you to answer the question, is neon able to bond with other atoms? For this for the Okay, when you are determining the number of valence electrons in the atom, we need to look at the group numbers. It is used to determine the amount of valence electrons in an atom. Beryllium is in group 2. Therefore, it has 2 valence electrons. Oxygen is in group 16. We only look at the last digit when we are finding our valence electrons. Therefore, oxygen has 6 valence electrons. Helium is an exception in group 18 because it only has a total of 2 electrons. So let's draw our atomic diagrams of the elements using the group numbers. So we're going to say that this is group 1, 2, 13, 14, 15, 16, 17, 18. Gotcha. Then let's draw our Lewis dot diagram. Hydrogen belongs to group 1, therefore only has one valence electron. Below hydrogen, we have lithium. Again, it only has one valence electron. Beside lithium, we have beryllium. So it doesn't matter where you put the electron, as long as you are distributing them through the domains before you buddy them up. Beside beryllium in group 13, there is boron. Boron has 3. Carbon has 4. Nitrogen has 5. Now notice how I give an electron to each domain before I partner them up. Okay? Oxygen has 6. So again, 1, 2, 3, 4, 5, 6. Fluorine has 1, 2, 3, 4, 5, 6, 7. Again, it doesn't matter where your bonding electron ends up or where your lone pairs end up, as long as you have the correct number of bonding electrons and the correct number of lone pairs. Beside fluorine, we have neon, which has a full valence of 8. And then helium only has 2. Notice how for helium, I didn't pair them up. Helium is on its first energy level, which maxes out at 2. Electrons do not like to be beside each other because they are both negatively charged, so they repel each other. So you want to spread those electrons around the atom evenly. So to recap, when you are drawing a Lewis dot diagram for an atom, you're first going to determine the number of valence electrons. Sulfur is in group 16, therefore it has 6 valence electrons. Step 2 says that we write the element symbol and then distribute the valence electrons evenly in the electron domain. So we draw sulfur, it has 6, we distribute the 4 first, and then we partner them up. Okay, we're going to take a moment now. I'm going to give you 5 minutes to fill in this table, and then we will review it up on the board. Okay, so you guys can check your answers. Let's do nitrogen together. So let's draw the Lewis dot diagram. Start off by distributing 4 electrons in our domain, but we need 5, so I partner 1 up. The number of bonding electrons, we have 3 in nitrogen, and we have 1 lone pair. There are 4 electron domains that are being occupied. Or you can add the number of bonding electrons plus the number of lone pairs, and it will equal the number of occupied electron domains. Now we're going to start taking a look at Lewis dot diagrams of ions. So again, to recap, the process of ionization is the process of losing or gaining electrons to achieve a full valence. Remember, atoms are unhappy when their valence is not complete. Metals form a positive ion or a cation by losing electrons. Remember, when you lose negativity in your life, you become a positive person. Non-metals form negative ions by gaining electrons. Okay, so anions are created by gaining electrons. When you gain negativity in your life, you become a negative person. Okay, taking a look at this diagram here, we have a sodium atom, and we notice this valence electron, there is just one. So what happens through the process of ionization is this electron is lost, okay? Sodium is part of group 1, and it'll explosively react when it is put into water or with other atoms, because it's just one electron away from being happy, okay? So then we notice that that outer shell disappears on the sodium atom, and we gain a positive charge. Moving on to the fluorine atom, we'll notice that there is a vacant spot there for an electron. So fluorine, again, will grab an electron from wherever it can get it, and then it'll have a complete octet, and it'll form a fluoride ion. Well, it should just be called fluoride. When drawing a Lewis dot diagram for an ion, they must be shown in square brackets. So, for example, sodium is an atom, okay? So it's an atom. Therefore, it has no square brackets. This is what sodium looks like. Sodium ion is an ion. Therefore, it would have square brackets. Now, so sodium is going to lose that one electron. It's going to have an empty valence. It lost one electron to have a positive charge. Notice how that charge is on the outside of the square brackets. Okay, for this next example, we are going to draw Lewis dot diagrams for the following ions. Let's first look at the atom version of these ions. So magnesium would have 2 valence electrons. Okay, this is an atom of magnesium. It has not undergone ionization. Versus the ion. So when magnesium undergoes ionization, it will lose the 2 electrons to get a positive 2 charge. Okay? Moving on, let's take a look at oxide. So oxygen, the atom, has 6 valence electrons. 1, 2, 3, 4, 6. Again, see how me placing those electrons around doesn't matter as long as I have the appropriate number of bonding electrons and lone pairs. So this is the atom. It's called oxygen. Now let's take a look at the ion version. So oxygen is going to gain 2 electrons. We're going to give it the square brackets, and it's going to have a negative 2 charge. So this is the ion, and we will call it oxide. Okay, I want you to draw the Lewis dot diagrams for the aluminum ion and the bromide ion. All right, let's see how you guys did. For aluminum ion, your Lewis dot diagram will look like this. Your bromide will look like this. Okay? I want you to now describe 2 trends that you see in metal ions and non-metal ions. Okay, so for the metal ions, we brainstorm that they lose electrons, they have an empty valence, and they have a positive ion. The non-metals, do they lose or gain? They gain electrons. empty valence or positive or full? They have a full valence. And what type of charge? Negative. Good. Ionic compounds are formed when there is a transfer of electrons. The transfer of electrons is used to form an ionic bond. So in ionic compounds, we form ionic bonds. In this little animation here, we notice that sodium is donating or transferring its electron to fluorine, okay, to form a sodium ion and a fluoride ion. This compound is called sodium fluoride. Okay, so now, when drawing a Lewis dot diagram for an ionic compound, the first step is to write a chemical formula. For lithium oxide, the chemical formula will be Li2O. Then we will determine the charge on the ions and draw ions with square brackets and coefficient. So we have Li2O. Lithium loses how many electrons? 1 to give it a charge of positive 1, okay? How many lithiums do I have? 2, so I give this a coefficient of 2. Oxygen becomes oxide by gaining how many electrons? 2, it gains 1, 2 to give it a negative 2 charge. Okay, so this is what your final answer would look like. Now I'm going to show you what's happening behind the scenes. We have 2 lithium, right? And they each have a valence electron of 1. Versus 1 oxygen, which has 6 valence electrons. What's happening is lithium is transferring its electrons to oxide to form these 2 ions. Okay, so lithium donates its 2 electrons to oxygen to make oxide and lithium ion. Example 5, draw the Lewis dot diagram for the following ionic compounds. So this one, we already have a chemical formula written. So magnesium has a positive 2 charge because it loses 2 electrons, which is combined with 2 bromines, which gained an electron each, the negative charge. So again, what is happening is we have a magnesium that has 2 electrons, and we have 2 bromide ions. Okay, so behind the scenes, magnesium gives 1 of its electrons to the first bromide, and its second electron to the second bromide, which then makes the compound magnesium bromide. Okay, so again, that's behind the scenes. This here is our final answer. Okay, let's do aluminum oxide next. So let's say we're given the name. So you need to first write a chemical formula. The chemical formula for aluminum oxide is Al2O3. So now let's write out our ionic, let's do the Lewis dot diagram. We have 2 aluminums that lost 3 electrons each, which is combining with 3 oxygens that gained 2 electrons each. Now, the net charge of this compound is 0. So we can check the net charge of our Lewis dot diagram as well. 2 times positive 3 gives me positive 6. 3 times negative 2 gives me negative 6 for a net charge of 0. So this is another way to double check that you've drawn the correct Lewis dot diagram. I'm going to give you a moment. You're going to do B and D on your own, and then we'll take it back up when we're ready. Okay, there are the answers for B and D. Okay, please make sure that you have the coefficients in front, and make sure that your chemical formula for magnesium oxide is correct.